In this video, I'm going to talk about constraint motion. Sometimes in our system we have multiple masses, but they are not independent from each other. Like for example, this example, we have two masses here, but they are connected to each other with these cables and pulleys. If I move B, A is gonna move. If you move A, B is gonna move. So they are not totally independent from each other. Their velocity and also their acceleration, their position, they're gonna be related to each other. How we should deal with these problems or with these systems in general? We should find the constraint between the objects and use those constraints to relate the velocity and acceleration of the objects to each other. I'm going to show that process with this example and also many more examples in the next videos. So for example, here in this problem we have these two masses and we know the velocity of A is 3.6 foot per second to the right. So this mass is going to move to the right with this velocity. And we are supposed to find the velocity of B. So how should I relate these velocities together? Sometimes students try to imagine what's going on. For example, if this one moves 1 meter to the right, how this one is going to move, and then use their imagination to solve this type of problems. But never do that. There are some simpler ways to do this. To solve this type of problems, first of all, we need to use some variables to show the location of the masses. For example, if I use this distance to show the location of B, let's call it Y. If I give you Y, then you know what is the location of B, right? And we can do the same thing for A. For example, the distance from here to here. If I call it X, then this distance. And if I give you this distance X, then you are gonna know what is the location of A. And you have many options to choose these variables. There is not only one solution. You can, for example, choose X from here to here. It doesn't really matter at the end. Then after finding or choosing the variables to show the location of your particles, you need to find what is the relationship between these variables. For example, here, what is the relationship between X and Y? Here is the moment that you need to figure out what is the physical constraint between your object, between the masses. In this problem, this cable is the thing that which is relating these two particles together, and the length of this cable is not going to change because the length of the cable is constant. If you move B, A is going to move. But if it was something like a spring, then you can, for example, keep A here and move B. They become independent from each other. But we don't have that case here. We have this rope with a constant length. And because the length of the rope is constant, movement of A and B, they are related to each other. They are not independent from each other. So we need to write down that constraint. The length of the cable in this problem is going to be equal to Y. From here to here is Y. And also from here to here of the cable, same thing here and same thing here, they are equal to X. So I'm going to have Y plus 3 times X. And also all the time, it doesn't matter where is the location of B or A, I'm going to have this constant length all the time. Again, independent from the location of A and B. And also a piece of the cable here, a piece of it here, a piece of it here. And these lengths, they are not changing. They are not changing with the movement of A and B. So I'm going to have a constant number here, a constant number here, here, and here. If I add all of them together, I'm going to have a constant number at the end. This is the physical constraint that we have in this problem, which relates X and Y together. Now, how can I use this to solve my problem? I can take a derivative of this constraint equation. Derivative of the length with respect to time is going to be equal to 0. because the length is not changing. Derivative of y is going to be y dot. Derivative of 3x is going to be 3x dot. And derivative of any constant number with respect to time is equal to 0. Now, x dot and y dot, they show the velocity of A and B. But in what direction we are going to talk about that? So this equation is going to relate the velocity of my objects to each other. For example, here, the problem says velocity of A is 3.6 feet per second to the right. So if A moves to the right, x is going to decrease, right? So x dot in this problem is going to be negative 3.6 foot per second. If A moves to the left, then x is gonna increase, so x dot is gonna be positive. But here it is negative because the object is moving to the right. So if I put this here, I'm gonna be able to find y dot. So from this equation, y dot is gonna be equal to negative 3 times x dot. So it's gonna be 10.8 feet per second. And it's going to be positive. So y dot is going to be positive. Now, what's the meaning of y dot for the velocity of B? Y dot is positive, it means y is increasing, right? So if it increases, it means velocity of B is going to be in this direction. Velocity of B is going to be equal to y dot downward. So it's going to be 10.8 foot per second, and the direction is downward. If I have some information about, if I was given some information about acceleration, I can take another derivative from the constraint equation to find the relationship between acceleration of my particles. I don't have it here, but if I need it, then I can take another derivative from this, and I'm going to have 0 is equal to y double dot plus 3 times x double dot.